This is the first part of chapter 6.4, and we will talk about general overview of the Gram-Schmidt process or process of orthogonalization. So the final goal of the Gram-Schmidt process is to get the set of orthogonal or even orthonormal vectors. And we will call this orthogonal set from V1 to Vn. And we usually start this process from a subspace, let's say W, which is spanned by some kind of vector from x1 to x2 and as many as we have. And that vector x is generally a basis for our subspace W, but they are not orthogonal. Gram-Schmidt orthogonalization convert them into the orthogonal or orthonormal set. And this is just an algorithm. You follow the step, you guarantee to have an orthogonal or orthonormal basis. And theorem 11 in this chapter is basically give us the protocol for getting this kind of orthogonal basis. So, and we started with the basis of P vector from x1 to xp, which is in the subspace W, which is subspace of Rn. So we start this process with a very simple step 1. We take our first vector x1 and we proclaim that this first vector will be our first orthogonal vector V1. And that's that simple. We just change the name here. Okay, and moving to the next step. So now we need to find the second vector, which is orthogonal to our first vector, V1. And of course, the easiest way to do it is using orthogonal projection. We take the second basis vector, x2, and we project it in our vector V1. And then, just by the construction, we will have an orthogonal vector, which we'll call V2, which is just the difference between the vectors x2 and V1. And we can use the projection formula to actually calculate this vector V2 precisely. And this is a recursive formula. So we calculate V1 in the first step, and we're using V1 in the second step. Okay, now we have two orthogonal vectors, V1 and V2. How we can find the third one? That is, we're going to the third steps of the process. Okay, we take now our orthogonal set, V1 and V2, and we span a subspace through it, and we call it a W2. So, and our vector V1, and of course it's two-dimensional subspace, so it's a plane which contain our orthogonal set V1 and V2. Okay, now we take our first basis vector x3 and we project it in the subspace W2. And again, because we are projection, we have this orthogonal space, which is just the difference between our vector x3 and its projection. And we will call this third orthogonal vector V3. And of course, we can use the projection formula to calculate it. And again, it's a recursive one. To find V3, we use in vector x1, x2, x3, and the vector V1 and V2. And we will continue this process until we basically run out of vectors x. So we will get at the end the p vectors from V1 to Vp, and those vectors will form an orthogonal basis. And we'll even can go ahead and normalize this vector, that is, we take each vector divided by its length and get the vector which length is equal 1. And at the end, we will get a orthonormal basis, which covers the same suspect as our original basis x. And in the next parts of this series, we will look at a couple examples of finding this orthogonal or orthonormal set.